All right, now this question is about electricity and the energy changes. The diagram shows a heater coil and a resistor connected to a 12-volt battery and an ammeter. Okay, the ammeter reading is 1.2 ampere. Since we know that current unit of current is ampere and ammeter is connected here, so the direction of the current, it is going like this in this way. Okay, and then it goes on. So what happened to the resistor? It takes the energy, right? State the equation linking voltage, current, and resistance. So we all know V is equal to IR, right? From the statement of Ohm's law, we come up with this mathematical expression: V is equal to IR, where V is voltage, I is current, and resistance. The next question is about calculate the voltage across 4 ohm resistor. Voltage across 4 ohm resistor. Uh, Assalamu alaikum.
Sir, type didn't answer.
Yes, yes. Um, yeah. What are you saying?
Type didn't answer.
Oh, okay. I think he is busy. So what are we getting? 1.2 times 4? 1.2 times 4, it's going to be how much?
4.8.
4.8 volts, right? So 4.8 volt. Okay. Now show that voltage across the heater coil is 7 volt. Is the heater connected? Is the heater connected in series? Yes, heater is connected in
Yeah.
series. Okay. So in series, remember voltage always divides, right? Okay.
Yeah.
Heater is connected in series. And remember, uh, let let me give you a very simple example. If I have if I have 12 volt here, if I have 3 volt drop at this resistor, and at this resistor, if I have 7 volt, so what will be the voltage drop at R3? So you will subtract these all voltages, the sum of these all voltages, okay? So 12 minus 10, you will get 2. So 2 volt, whatever the remaining voltages will be dropped at the R3 resistor, okay? Now,
Sir,
yes,
what do you send the recording to us?
sorry.
What do you send the recording of the class to us?
Yeah, I'll send you.
Okay.
So heater is connected in series, okay? So what is the total voltage that we have? What is the total voltage that is also called EMF? Yes, EMF, that is the
Electromagnetic
battery voltage.
force.
Yeah, battery voltages as well. Okay, so what we can do is 12 minus, what is the amount of voltage across the 4 ohm? 4.8. Can we subtract 4.8 from 12 volt? So what are we getting?
7.2.
7.2 volt. Clear? All right.
Yeah.
7.2 volt across the heater, right? Across the heater. Now, calculate the energy transfer to the heater coil in 5 minutes. So what we know that time is given in minutes, so we have to convert in seconds, right? You have to convert in seconds.
300.
And what we know about the energy transfer, if we recall the concept of power, power is energy transfer upon time, right? And if I want to find out the energy, I have to multiply this time with the power. So power times time is the energy transfer. The electrical power is actually the product of voltage and current. Okay. Electrical power is what? Voltage times current. Okay. So the formula that we have obtained here for the energy transfer, it is VIT. VIT, where V is the voltage, I is the current, and T is the time, right? So
Okay.
energy equals to voltage. How much voltage that we have across the heater? Across the heater, 7.2. Yes.
Yeah.
Yeah, are you getting this concept?
Yeah.
And what's the current through the heater? Since we know that in series current remains same, right? Current remains same, and current does not have any other path to split up. Therefore, the same amount of current flows through each resistor or each component. Similarly, whatever the current that is actually shown by the ammeter in this circuit will have to flow through the 4 ohm resistor and will have to flow through the heater coil as well. Okay. So what is the current that is flowing through the heater coil? That is 1.2 ampere. Okay.
Okay.
And for how much time, for how long the power is supplied to the heater? For
5 minutes.
seconds, 5 times
Three
60. So
300.
300 seconds. Okay, for 300 seconds, we have done this. So what should be the answer? 7.2 times 1.2 times 300. Yes.
1 minute.
Okay, so the answer is 26, almost 2600, right? I think so.
1 minute. Was 1.2 times 7.2.
You can cross check it. At the first,
Times.
at the first, the temperature of the water increases. Temperature of the water. Okay, so heating coil is there. Heating coil is there. You can see here, and it is inserted in the water, right? It is inserted in the water. So the water will gain the thermal energy, right? As the
Yeah.
heater gets heated, okay, so it will supply the thermal energy to the water, right? So after a while,
Yeah.
the temperature reaches a steady value below the boiling point of the water. Explain why the temperature reaches a steady value. Why the temperature is not changing. So we all know that are we changing the supply? Are we changing the input? Acha, okay, let me tell me what is the input or what is the form of the input. Input is in the form of electrical energy. Yes, input is in the form of electrical energy. Yeah.
Yeah.
Are
Yeah.
we, and how can we increase or decrease this energy transfer? in this electrical circuit, how can we increase or decrease the energy transfer?
Reducing the
By
voltage.
changing the amount of current? Yes.
Yeah.
By changing the EMF? If I increase the EMF, will the energy transfer be more?
Yeah.
If I increase the value of voltage, will the energy transfer will also be increased?
Yeah.
If I increase the amount of current, will the energy transfer will also be maximum? Will the energy transfer be maximum or increased?
Yeah.
So that means there there are the ways through which we can increase the input. And when you increase the input, then the output will also be increased, right? Depending on the efficiency. Clear? So the thing is
Yeah.
that the question says temperature is not changing. It has reached to the steady value. The temperature is not changing. It has reached to steady value. Okay. Temperature reaches to the steady value means a temperature has become constant. So why the temperature has become constant? Because whatever the energy that was given as an input, all the energy is transferred to the output. Clear? So are we going to
Yeah.
run out of the energy? Yes.
Yeah.
We do not have any more energy in the battery. If we do not have more energy, so what will happen? The temperature will stop rising. Clear? Okay. So
Okay.
uh, input input given in the form of electrical energy equals to the output in the form of in the form of thermal energy. And from where thermal energy is coming out? From the heater, right?
The heat.
Yeah, from
The
the
heater coil.
heater coil, okay? In the form of thermal energy. So whatever the rate of energy transfer as an input, okay? Whatever the energy, so rate of energy loss will be equal to rate of energy gained or supplied. Okay, so the energy that is given is actually given in the form of electrical, okay, in the form of electrical energy. So that electrical energy transfers to the thermal energy, and we are not changing, we are not varying the electrical energy. Therefore, no change of temperature will be observed. Now,
Okay.
this question is about the connection of the circuit like series or parallel. If you can see here, there's only one path for the circuit for the current to flow, right? And if you can see here in this circuit, there are multiple paths, okay, for the current to split up. Clear? Right? There are
Yeah.
multiple ways, one way, two way, three way, and third way. But there's only one way. The current does not have any other path to to split up. The current does not have any other path to split up. Right? Clear?
Yeah.
Yeah.
So this X is going to be a series. Okay. So X is a series one and Y is a parallel one. Okay. Y circuit is
Okay.
parallel. That means the current divides. Okay. And in series, Assalamu alaikum type. And in series, the current has only one path, right? Current
Yeah.
has type joint.
Yeah.
Oh, okay. Current has one path. Clear? And current in parallel current has multiple paths. Okay.
Okay.
All right. Now describe the advantages and disadvantages of design X when used as a heater in a car window. Okay. So X is actually what? Is a series circuit. Now they are saying what is the disadvantage and disadvantage of having a series circuit or a series connection of the heater in the car window. Since you know that in a series circuit, we can control the whole circuit with one switch, right? Yeah.
Yeah.
So less wire will be needed. What do you think?
Yeah.
In a series circuit, we have only we can have one switch to control the whole circuit, to control the entire circuit, right? So in a design X, we have one control, one control or one switch to control the heater and car window, right? Number one. Number
Yeah.
two is less wires will be needed. Yes, less wires, less number of wires will be needed. Yeah. Do you agree with this? Less number,
Yes.
less number of wires will be needed, right? So
Yeah.
this is going to be your advantage. And disadvantage could be what happens if one component fails. So what happened with the other
No.
components?
For a series, all of them will stop.
Yes, because if I say that here is a series circuit, again I am going to draw one for you. If I have a series circuit, right? So if one fails, so what happened? The current will not be able to flow. The current will stop flowing through the circuit. Okay. The current cannot flow through the circuit. Clear? So having one having one component faulty in a series circuit will make a whole circuit unsuccessful or disconnected. Okay. Clear?
Yeah.
Right? Taib, are you also getting this?
Yeah.
Okay. Yahya, are you there?
Yeah.
All right. Okay. So disadvantage, if if one if one component if one component fails, other won't work or function. Okay. Other won't function or work. Clear? Right?
Yeah.
Any other disadvantage do you think we can have here? Can I control the window and the heating coil separately?
No.
Yes, boys. Can I control
No.
can I control heater and car window separately, independently? No, right? So heater and car window, heater and car window cannot cannot be controlled separately or independently. Okay. I hope this concept is clear, right?
Yeah.
Now, uh, another question, the diagram shows part of a lighting circuit in a house. The circuit is protected by a fuse. And you can see here the fuse is connected. Give two reasons why the lamps are wired in parallel. Now, look at the question. The question says that this is actually the part of the circuit of a lighting circuit, right, in a house, right? So, do we always control all the lights with one switch? Or
No.
do we have the multiple switches for multiple components to be controlled?
Multiple switches.
Yes. So you can see here they all are being controlled with separate switches, right? Independently. Okay. Each lamp is being controlled independently. So what we can say, each lamp is controlled by an independent switch. Okay. By an independent switch or separate switch. Yeah.
Yeah.
And what could be another reason that can be included here?
If one lamp breaks, the others can still work.
Oh, wow, good. So that could be the advantage, right?
Yeah.
Okay. So what if I say that each lamp should get a same voltage? So there should be no reduction in the light or in the brightness, right?
Yeah.
Number one. And number two is what we can say that in house, it is not necessary in house that we have only one room. So multiple rooms can have multiple lamps. Okay. Right. So in a house, there may be multiple rooms. So each lamp can be connected in different rooms, right? Clear? Each, each lamp should get each lamp should get same voltages. Clear? Any question, any confusion here?
No.
Okay, Yahya and Tai, do you have
No.
any question?
No.
Okay, so what is the current in P? Okay, what is the current at P? Yeah, at P. Okay, yeah, here we have P. What is the current at point P? So since we know that it's a AC current, so if I take this direction of the current, it is passing through the fuse and then it reaches at this point, it splits up. It reaches at this point, it splits up here, it splits up here, it splits up here, it splits up here. So then it goes down and then it comes back, right? This is the route, this is the way how current flows in the circuit, right? So do you think that all current are going to be added? Yeah.
Yeah.
No.
Yeah, they are going to. They are going to be added. Okay. Since they are this the circuit is parallel, so each current is going to be added, right? To find out the
Also,
total current. Okay. To
in
find out
parallel
the
circuit, all currents will be added.
yeah, because in the beginning of the circuit, what happens that when the total current starts flowing, so it splits up in different branches, right? Okay.
Yeah.
And then each branch current is going to be added further to make a total. Okay.
Okay.
So 0.26 plus 0.43 plus 0.17 plus 0.26. Can anyone make a total, please?
1.38.
1.38, clear? Right?
Yeah.
Explain how the fuse protects the circuit. You you have already studied about the fuse, that it's a protecting device, right? It protects the circuit. Whatever, whenever the any large amount of current, okay, enters the circuit, so it disconnect itself, it breaks its wire, right? Yeah.
Yeah.
Okay. Any other point do you think that that can be added in a fuse? How does it work?
Um.
Yes, guys.
Um.
All right. So, okay, fine. We have just 3 minutes for this class. So, inshallah, we'll continue in the next class, but I'm going to complete this. So, fuse is, since it's a protective device or a safety device, right? Okay.
Yeah.
Fuse is a safety device, right? And
Yeah.
it has a thin wire, right? It has a
Yeah.
thin wire. Okay. And this wire is designed to melt and break the circuit, right? So
Yeah.
this is designed to break the circuit when 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 excessive, right? Excessive or large amount of current, right? Large current flows or enters through it. Clear? So it's safe, it disconnect itself so that other components they remain safe, right? Right? So
Yeah.
what should I write here? When the excessive current enters, so what happens? The wire of the fuse melts, right? Okay, clear?
Don't hit me.
When excessive current enters, the 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 fuse breaks or wire melts, right? Okay. So what happens? The current is cut off. Okay. It it can prevent it can prevent um, from overheating, number one, and it can prevent from damage of components. Clear? This is how the fuse works,
Yeah.
right? And it is always
Yeah.
connected with the live wire, remember. Okay.
Okay.
Now power equals to voltage